Dear students, today we discuss about the oscillators. What are oscillators? Oscillator is a linear electronic circuit which produces the oscillation in its output. Oscillation means the sine wave. It is a sine wave. It is an electronic circuit which produces the oscillation, that is a sine wave in its output. We know well about the amplifier. What is amplifier? Amplifier is the electronic circuit which produces a output. It amplifies the input signal given at the input and gives the amplified output. Okay. Then what is oscillator? Oscillator also gives a sine wave output form. The main difference between the amplifier and oscillator is the amplifier amplifies only when the input signal is given to the circuit. But in the case of oscillator, the circuit will spontaneously produce the output waveform without giving any input signal. The oscillators produces a output waveform. But in the case of the amplifier, when the input signal is given, then only it produces the amplified output. See, this is a CRO, cathode ray oscilloscope. Here, it is used to determine the frequency of the sine wave, the waves produced by the oscillators. So, this is a sine wave. It is the y-axis. It is the x-axis. In x-axis, the one wave is known as it is the one wave is measured from the peak to peak, or from this point to this point. So, to determine the time period is equal to length into time. How the length is determined? See here, this unit is taken as 1, this unit is taken as 2, this unit is taken as 3. So, length is measured from this point to this point, 1, 2, 3. So, the length is 3. How the time is determined? Here I have mentioned it is in millisecond. See here in oscilloscope, cathode ray oscilloscope, the time knob is in millisecond mode. So, I have put millisecond. So, 3 into 10 power minus 3 second. In y-axis, we can measure the amplitude. It is the 1 unit. The 1 unit is equal to 1 volt. So, 1 volt, 2 volt, 3 volt and 4 volt. So, the y-axis indicates the amplitude, the voltage. It is taken as 4 volt. To vary this, we can adjust the amplitude knob here. The amplitude knob indicates the 1 volt. So, 1 into this division, 4 divisions, 1, 2, 3, 4. So, in this oscilloscope, we can determine the time period. From this, we can determine the frequency of the wave and the amplitude of the wave. We know that the oscillator is a linear electronic circuit which spontaneously produces the output waves. To produce the output wave without giving any ACC input signal, a condition is needed. This condition is known as Barkhausen criterion. The Barkhausen criterion is a mathematical condition, a rule to determine when the oscillator will oscillate. You know well that already we have studied the feedback amplifier. It is the feedback amplifier. It is an amplifier with the gain A. The initial input is V source and it gives a V output. From the V output, we are taking a part of the output voltage, that is a feedback part. This feedback ratio beta is, now the V output is act as a input to this feedback circuit. So it is a negative feedback. So it is taken minus Vf is equal to beta V output. That is minus Vf divided by V output is equal to beta. Beta is the feedback gain. So again it is coming here. So total input voltage Vi is V source minus V feedback. So in the case of negative feedback, we get the gain A by 1 plus A beta. But it is the negative feedback. In the case of the positive feedback, we get A divided by 1 minus beta A. Okay, here the beta A is nothing but a loop gain. What is beta A? Beta A is a loop gain. When the loop gain is equal to 1, that is equal to unity, when the loop gain takes the value 1, substitute this in this equation, 1 minus 1, you get 0. A divided by 0 is equal to infinity. So it is the condition to produce the oscillation in the oscillator, even without giving any input signal. It gives the output waveform. To get the output waveform without giving any input, we need a condition. This condition is equal to A by 1 minus beta A. The main condition is a loop gain should be equal to 1. When loop gain is unity, you will get the transfer function gain. Positive feedback is infinity. So it produces the oscillation without giving any input in the case of oscillator. This condition, determinant beta A is equal to 1, loop gain is equal to 1, loop gain is equal to unity, is called Barkhausen criterion. Now we discuss detail about oscillator. You know that oscillator is an electronic circuit which produces a continuous, repeated, alternating waveform without any input signal, which generates as sine wave, cosine wave when excited by DC input supply voltage. The energy is taken from DC input supply voltage. This is the output waveform. The length is measured here. The amplitude is measured here. From this we can measure the time period. From the time period we can determine the frequency. Frequency is equal to reciprocal of time period. Okay. So what is the main part? The main part of the oscillator. The main part of the oscillator is a tank circuit. The oscillator consists of a tank circuit, it is the main part, and then amplifier, and then a feedback network. The oscillator consists of three parts. The main part is tank circuit. The second part is amplifier. Third part is feedback network. So, the main part of the oscillator here is a tank circuit. The tank circuit produces damped output waveform. Okay, it is the main part which produces the oscillation. So, the main part of the oscillator, the tank circuit, that consists of capacitor and inductor. The oscillators are divided into two types. One is LC oscillator and another one is RC oscillator. What is LC oscillator? If the tank circuit of the oscillator consists of a capacitor and inductor, this type of oscillator is called as LC oscillators. They are Hartley and Colpit oscillators. If the main part of the oscillator is a tank circuit, if the tank circuit consists of a resistor and capacitor, then this type of oscillator is known as RC oscillator. Example is Wein bridge oscillator, phase shift oscillator, etc. So, first we see the LC oscillator. The LC oscillator tank circuit consists of the inductor and capacitor. The inductor and capacitor are connected in parallel with a voltage source. See here, it is the tank circuit in the LC oscillators. It is the inductor coil, it is the capacitor, it is the voltage source. Initially, this pole is connected to point A. Then it is a voltage source. This voltage passing through this and +1. So it charges the capacitor. The negative voltage is coming here. So here plus, here minus. It charges the capacitor. So it charges the capacitor fully. The capacitor will charge to a voltage V, which is the voltage source here. So using this voltage source, the capacitor charges fully. Okay. Now this pole is moved to position B. When it is moved to position B, the capacitor plus and minus starts to discharge through this wire to the inductor coil. So the plus positive voltage is coming here and fed to this point, and the negative voltage is from the capacitor coming here and fed to inductor coil. So a DC voltage is fed to the inductor coil. You know well that Faraday's law of induction, when a current is passing through a coil of wire, the coil produces the magnetic field. The magnetic field produced in the coil depends upon the intensity of the current passing through the coil. So if a current passing through a coil, the coil produces the magnetic field. Now, the capacitor C will start discharging through the inductor coil. On discharging, the voltage across the capacitor will start to decrease and current through the inductor starts increasing. So this increasing current creates electromagnetic field in this coil. Now, when the coil is fully discharged, there is no further electrostatic energy stored in the capacitor to supply a current. So, the produced electromagnetic field now starts to decrease, starts to fall. Due to this falling, now you come to the Lenz's law. When a coil is moving in a magnetic field, when a coil cuts a magnetic field of lines, then a induced EMF is produced in the coil. When a coil is moved in a magnetic field, the induced EMF is produced in the coil, or a magnet is passing through the induction coil, the induced EMF is produced in the coil. Here, the magnetic field of line starts to decrease. It is equivalent to a coil cuts the magnetic field lines. So, a induced EMF is produced. According to Lenz's law, the induced EMF is in negative sign, that is opposite to the current responsible to produce this magnetic field. So, the induced EMF produced here is in opposite sign to the current responsible to produce this magnetic field. So, see here, the current responsible to produce this magnetic field is positive here. So, induced EMF produced by this coil on shrinking of magnetic field is negative. Again, here negative, automatically here positive. Again, this negative voltage goes and charges, third and then fourth, charges the capacitor. Here automatically positive. So, this induced EMF charges the capacitor. It charges fully and again it starts to discharge. See here, this negative voltage again coming here. So, here now negative, automatically here positive. Now, this negative voltage and this positive voltage again produces the magnetic field. This magnetic field starts to fall or shrink after fully discharge of this capacitor. So, now here the induced EMF is produced with opposite side, that is plus. This plus positive voltage again goes and charges this capacitor. Here automatically negative voltage. So, here positive, here negative. Again this voltage charges the capacitor. Again, after charging fully, the capacitor starts to discharge. Again a positive voltage is given here, negative voltage is given here. Again a magnetic field produced and the magnetic field starts to shrink. So, the induced EMF produces with opposite sign. So, the negative voltage is produced. So, negative voltage charges the capacitor. Again, the process repeats. But due to the reactance, that is the resistance produced in the capacitor, and the inductance coil, it resists the voltage. Due to this resistance, the voltage charges and discharges goes on decreasing. So, it produces a damped wave. What is it? It produces a damped wave. Initially, the intensity is high and then it goes on decreasing. At a particular time, the oscillation stops down. So, to get the continuous undamped wave, we need some other circuit. This circuit is nothing but the amplifier and a positive feedback net. So the oscillatory circuit consists in the case of LC oscillators, capacitor and inductors. In the case of RC oscillator, resistor and capacitor produces damped wave. This damped wave is fed back with the positive feedback network to the amplifier. The amplifier amplifies and gives the undamped output waveform with constant amplitude. It is the simple working of the oscillator.